Jupiter is not just a planet, it is a failed solar system. If Jupiter were about 80 times more massive, it could have ignited to become a second star. But even though it failed to shine like a sun, it remains the absolute king of the planets. Imagine the scale. Jupiter is 2.5 times more massive than all the other planets in the solar system combined. Its volume is so colossal that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a standard basketball. But why did it become such a monster? Modern astronomers are debating two main theories about Jupiter's early meal. The first is the core accretion model. This is the most popular theory. About 4.5 billion years ago, in the chaotic protoplanetary disk, a core of rock and ice formed. When this core reached a mass 10 times that of Earth, its gravity became so intense that it triggered a runaway gas accretion effect. It began swallowing the surrounding hydrogen and helium at a dizzying speed, bloating up in just a few million years. The second is the disk instability model. A bolder hypothesis suggests that Jupiter did not need a rock core to start. Instead, it was born directly from the collapse of a massive cloud of gas and dust due to gravitational instability, exactly like how a star is born. Whichever way it happened, the result is a gas giant that dominates the sky. However, humanity only truly began to understand the outer shell of this giant thanks to pioneer missions. In 1974, the Pioneer 11 spacecraft flew by, sending back the first grainy close-up images. In 1979, Voyager 1 flew by, revealing a violently churning atmosphere unlike anything we had ever seen. But those photos were just the outer skin. To understand the heart of this monster, we needed a shocking event. In the 90s, an unprecedented event completely changed our view of safety in the cosmos. It was the arrival of Comet Shoemaker-Levy 9. In July 1994, the world held its breath. This comet was no longer intact. Earlier, when it flew too close to Jupiter, the planet's terrifying tidal forces exceeded the Roche limit, tearing the comet into a chain of 21 fragments, looking like a string of pearls of death plunging into the abyss. They slammed into the Jovian atmosphere at a terrifying speed of 216,000 kilometers per hour. As fate would have it, the impact sites were on the dark side of Jupiter, hidden from Earth's view. The Hubble telescope, which had just been repaired, seemed helpless to record the moment of impact directly. But luckily, we had a spy on the way. The Galileo probe, launched in 1989, was in a unique position on the side of Jupiter. Galileo became the only witness in human history to see the explosions directly. The data Galileo sent back sent a chill down scientists' spines. Fragment G, the largest piece, created an explosion equivalent to 6 million megatons of TNT. In other words, it was 600 times more powerful than the entire nuclear arsenal of humanity combined. When Jupiter rotated, bringing the wound into view for the Hubble telescope, humanity was shocked. On Jupiter's cream-colored clouds appeared pitch-black scars. These were clouds of incinerated dust and gas, and the size of that scar alone was larger than the Earth. This event was not just a fireworks display. It proved that Jupiter acts as a shield, absorbing dangerous asteroids. But sometimes, it is also a slinger that throws them toward the inner solar system. After the Galileo spacecraft ended its mission with a suicide dive into Jupiter in 2003, we discovered water, but the data was controversial because the ship had dived into an unusually dry region. It wasn't until 2011 that NASA launched Juno, a spacecraft armored to withstand deadly radiation, to settle the questions once and for all. In August 2016, Juno entered a polar orbit, scanning the entire planet from north to south. The curtain of mystery began to be lifted in terrifying detail. In the upper cloud layers, where the temperature is -145 degrees Celsius, Juno discovered a bizarre weather mechanism. Lightning on Jupiter doesn't just happen in water clouds like on Earth, but also in higher layers. Here, ammonia gas acts as anti-freeze, melting water ice to create a solution of liquid water and ammonia. When these liquid droplets rise, they freeze on the outside but remain liquid on the inside, forming hail lumps called mushballs. These balls fall, build up a charge, and generate massive lightning bolts, 1,000 times more powerful than lightning on Earth. Juno also revealed the secret of the Great Red Spot, the angry red eye that has watched us for 300 years. This storm is shrinking. It is currently about 16,000 kilometers wide, but its depth is the real story. Gravity data shows that the roots of this storm extend 300 to 500 kilometers deep into the planet, deeper than any ocean on Earth. Its signature red color is thought to be caused by ultraviolet light from the sun breaking down chemical molecules, creating a layer of brick-red sunscreen covering the storm. As the probe dives deeper below the clouds, reality begins to bend. There is no solid surface for you to stand on. The deeper you go, the more the pressure increases dramatically. The temperature rises. At a certain depth, hydrogen gas does not turn into liquid abruptly. Instead, it becomes a supercritical fluid. In this state, the boundary between gas and liquid disappears. You would travel through a fog that gets thicker and thicker, until you realize you are swimming in an ocean of liquid hydrogen without even noticing the transition. At a depth of about 20,000 kilometers, the pressure reaches 2 million atmospheres, which is 2 million times the atmospheric pressure of Earth. Here, a miracle of quantum physics occurs. The hydrogen atoms are squeezed so hard that their electrons are knocked out of orbit, turning the liquid hydrogen into an electrically conductive substance like metal. This is metallic hydrogen, the rarest and most mysterious fluid in the universe. It flows and churns inside Jupiter. It is the movement of this conductive metal ocean that generates Jupiter's massive magnetic field, which is so strong that it reaches all the way to the orbit of Saturn. But the most shocking discovery lies at the very bottom. Previously, we believed that Jupiter's core was a solid ball of rock and iron. But no. Data from Juno shows that its core is a type of diluted core. It is not solid, but fuzzy and dissolved. The boundary between the rock core and the metallic hydrogen ocean above is blurred. Its core occupies up to 50% of the planet's radius, but the density is lower than expected. Why is the core so shattered? The most convincing hypothesis today is that in the early days, a massive planetary embryo, about 10 times the size of Earth, smashed straight into the center of Jupiter. This fatal collision shattered the original solid core, causing rock and metal to be stirred up and mixed into the hydrogen gas layer above, forming a chaotic soup of matter that has existed to this very day. Jupiter is not just a planet. It is the most extreme laboratory, where matter is compressed to the limits of our understanding. From ammonia hailstorms and lightning tearing through the sky to oceans of liquid metal and a broken heart caused by an ancient collision, every time we think we understand Jupiter, the king throws us a new puzzle. The Juno mission will end in a few years, and after that, NASA's Europa Clipper will follow in its footsteps. The journey to decode this giant is not just to understand the solar system, but to understand how worlds are born and survive in the vast universe.